So we will continue from the last lecture that we discussed, and in that one we discussed about the principles of experimental research design, and we discussed three principles. Now we will discuss in today's lecture. My focus is to look at informal experimental designs. If you recap the previous one, you will find that uh, we talked about the causal and experimental design, and that too in two categories. Number one, informal experimental designs methods, and number two, formal experimental designs. So when we talk about informal experimental research designs, so we why we talk about informal experimental research design, because it talks about that overall or common learning of any experimental design, which can be easy to a layman. My point is that when you enter into formal research design or formal experimental design, that requires more statistical and analytical tools. And in formal research, experimental research design, you get the outcome or testing of your hypothesis very close to your result. Whereas in informal experimental design, this is general and common methods which are followed, and you will find that most of the time in your day to day life, you knowingly or unknowingly conduct your research on any issues or many issues by using either one of the informal experimental design. Say for example, if your mother says that go to the market and purchase half kg or 1 kg of sugar, so it is very simple that one thing is that before purchase, sometime you ask price of sugar in one market, one shop, then you go to second shop, then you compare the price. Similar procedure you do in your vegetable purchase. If you continuously purchase your vegetables from one thela or one shop, there are chances that your hypothesis, that hypothesis means that thela owner is very good in honest in giving you fair price. So if you design, if you make this hypothesis and you do not change thela, then it would be very difficult to prove that yes, your hypothesis is okay or correct or not correct. But if you change thela, maybe same day or maybe different days, then you can have a broad idea that to what extent your vegetable thela is honest. So informal experimental designs are those methods which usually you do in your daily life, whereas the formal experimental design requires more rigorous statistical and analytical tools, whereas this informal experimental designs doesn't require any strong statistical or analytical tools. So for example, the first method that we look into about the informal experimental design is before and after without control design. So okay, before taking this one, let us understand this control design, test area and control area basically. Say for example, if you want to test the effect of any dependent variable on relationship, causal relationship between dependent variable and independent variable, right? So you need to conduct experiment, and in that one your treatment is simply that when on test area you are applying that dependent factor. Say for example, if you take it that you want to learn that how fertile your land or your kitchen garden in your house is, right? Very simple thing. So you will say that how fertile is, that is one thing. Or if you want to test any you can say independent variable, effect of independent variable. Say for example, you bring some fertilizer. Say for example, half an hour fertilizer or chemical, and you want to study the effect of that chemical on your production or productivity or on your kitchen garden. So test area means your kitchen garden or land where you want to test it, and you need to go without control design. Now without control design means you do not have two areas at the same time and studying it. The whole area is treated as a test area, and then you look at the level of phenomenon before treatment. That means you see that if you put some type of, you do experiment and you say that productivity in the month of January with respect to X crop or X vegetable is this. That means within your kitchen garden area you get X amount of vegetable. Now you apply treatment means you add fertilizer or chemical to your soil. So treatment introduced, and then after treatment you measure the level of phenomenon, means maybe in this case productivity. Say for example, without treatment, before treatment you are getting 4 kg of, say for example, one type of vegetable, and after treatment if you get 5 kg of vegetable. So you can understand that the effect of fertilizer or chemical is y minus x. That means, and this simply 5 kg minus 4 kg means 1 kg. That means if you introduce this fertilizer, if you introduce this chemical, then your effect will be of this much. So this way you can simply understand that your hypothesis testing, that yes, using fertilizer or using chemical or using X treatment will result into this. Sometimes it is maybe that you apply some chemical treatment and this level of phenomena after treatment reduces to 2 kg maybe. So this may be your result which can reject your hypothesis. You say that after applying chemical you will increase your productivity, but it reduces. So it means your hypothesis is rejected, it's not accepted, your statement is not correct, your understanding is wrong. So this is simple, you know, one type of design where common man apply this type of, you know, before and after without control design, and we usually in routine we do it. Now the second type of informal experimental design is only after only with control design. That means you are not going to study the level of phenomenon before treatment, or you are not going to study the level of, you know, phenomenon without treatment, before treatment. You want to study after only, not before. So say for example, in this case, you are using with control design. With control design means, say for example, you have a kitchen garden area, and you divide your kitchen garden area, half area as a test area and half as a control area. So half land you control and half land you give treatment. So in half land you apply fertilizer, and in half land you do not apply anything, right? Now then you see the productivity after treatment, not before. So in half area you added chemical or fertilizer, and your production goes to Y. And the half area which was under your control, that means you control that area without treatment, without fertilizer, without chemical, and you studied the productivity. Say for example, in this it comes about 5 kg, and in this it comes about 4 kg. So you are only measuring after the experiment, not before experiment. So to what extent your chemical treatment or fertilizer addition would result, that can be, treatment effect can be very simple, and you do it. Say for example, how many times you say, I think every student does it. So for example, you say the effect of tea in making you active. It happens that if you are preparing for examination in night, and you see someone says that no, if you take a cup of tea, then you can study 1 hour extra with concentration, or you increase your concentration. So you want to study the effect of tea. Now effect of tea, either you can study with the first method, before and after. One day you test without tea, and next day you take tea and then you test. So before and after. Whereas you can look that you test area means one student and control area other student. So after only these are conducted in similar time. Look at similar time. This is very important condition. So student X and student Y living in same room. Student X is taking tea in the night, whereas student Y is not taking tea. Now look at who is, giving more concentration to time, or who is going to bed early, or is there any effect of tea or not. This is very common. You do it. because you only test after only with control design. And it is our, you know, in youth class it happens, you say that Mr. X has an effect on of T, but Y has not, or X has effect of some alcohol, but Y doesn't have. So you can look at this treatment in same area. You can choose one test area and you can choose control area another, and then you can look at the results. And this one is after treatment and this is without treatment, and one is called test area and other is called control area. So in case of tea or coffee, you can understand this. In case of chemical treatment, you can have half kitchen garden, and then you can look at this, that whether your treatment effect gives you result or not. So this one is second type of informal experimental design. Now third type of experimental design is before and after with control design. Now look at why this before and after with control design is required. Reason being is that there may be, when you are conducting with or without, there may be some extraneous factor which can result 1 kg extra yield, or extraneous factor can have effect, half effect, and half effect may be of your treatment. So here what you look at is that you have not proved same time period 1 and 2 areas are there, test area and control area. So time period 1 means maybe at the evening, 6 or 7 p.m. you look at before treatment X, and you look at the level of phenomenon without treatment. This is before treatment and this is called without treatment, because in control area you are not going to give treatment. So you can just nullify that extraneous factor in a more stronger way, and then you give treatment, and then after certain period, now you look at the yield effect of that treatment. So you can say in case of test area, your test area says that Y minus X would be in treatment condition, or the effect in control area, that means without treatment, if it is yield is A, and level of phenomenon without treatment in control, without treatment in time period is Z. So your treatment effect may be Y minus X minus Z minus A. How? Look at, you say that one student who will be measured before treatment and after treatment, that means without T, like say for example Monday, this student is tested that how many hours student study, right? Monday, look at, and control area, second student is also studied on same Monday, that how many hours this student studied. time period is same. Now treatment is given. Say for example, treatment is given at 9 p.m. and then after that second time period you measure X student, or you can say P student, after giving T or something like that, how many hours student study, and second student parallelly without treatment at night 9 or 11, how many hours study. Or take a different example of crop. You have half land for test area and half land for control area. Now say for example, for first time period you look at that crop productivity in test area and in control area. Say for example, you say that some crop is produced in this test area and crop area, some vegetable, and productivity comes like 4 kg or like 6 kg, something like that, right? Because maybe you say that the soil quality is different, maybe. So after treatment you give treatment, chemical treatment or something like that, and second land area is not given treatment. Then same crop is again tested after treatment, chemical treatment or fertilizer utilization in same land, and the same product or same crop is also tested here. So this will help you to neutralize the extraneous factor effect to a great extent, and you can study that effect of chemical treatment is what extent this fertilizer or chemical treatment or treatment, that means independent factors which can have effect on your dependent factor productivity. So you can very easily study and understand that how you look at the before and after control design. And I tell you, your parents keep on using this method when they have a kind of hypothesis or understanding or preconceived perception in their mind. So they test it, and they always use before and after with control design. They will repeatedly observe you in the same time period. Say for example, in morning they will observe you, and they will observe relative another one. Then they will observe, say for example, when you are going to school, they will monitor you, and they will monitor your control area also, your friend circle. And then in the evening they will monitor you, and they will monitor to your control area. And the treatment may be that one is going to school and one is not going to school, say for example, and then they will study your behavior, what is the change. So they can, there are many examples where you are being part of any informal experimental research. Maybe you are studied before and after with the control design, maybe after only with control design, or maybe without control design. So these three are basically life events. Every next day, if you look at from this angle, that who is experimenting with you, you can understand that there is something which is going on, and your behavior is being tested. So the person who is testing might have some specific understanding, perception, or image, and want to confirm it. So I'm just stopping here, and in next lecture we will try to cover formal experimental design. May not be in one lecture, but maybe in one or two lectures. So this is all about your today's lecture.